Hello everyone. In Embedded Linux Conference North America, this time over virtual conference, we saw about software update in Zephyr, and I also tried showing the demonstration for use case based on UpdateHub, and unfortunately due to the local environment or setup in my disk, I failed to show the demonstration for MCU Manager and as well as Hawkbit, and also due to the time limitation I couldn't extend the demonstration session. So this screencast is an effort to the continuation of the talk to show the demonstration for MCU Manager and as well as for Hawkbit, and I also, for the completeness, I will repeat the UpdateHub example and how to flash and use the software update for UpdateHub. For this, I have two different boards. One is the STM32L4 based discovery kit with me to use the Bluetooth and use the MCU Manager example over Bluetooth. And I have another board which is Freedom Development Kit based on K64 SoC. I will use this particular board for UpdateHub and as well as Hawkbit in my example. Now let's get started with the discovery kit, and I will show the example of flashing or using the software update based on the discovery kit. To get started, I have connected the discovery kit to my laptop, and I will show the basic example of how to build and flash an hello world sample in the discovery kit. Now I have compiled the Zephyr environment and the sample hello world, and I'm going to flash the simple example to the discovery kit, and now you can see the Zephyr is flashed and we can see the hello world example. So now we can jump into how we can use the MCU boot and as well as the MCU Manager example for this particular software update case. To start with, I will first compile the MCU boot and then flash the MCU boot, and then I will recompile the MCU Manager example, MCU Manager server example, and flash into the primary slot of the MCU Manager, and then it will the MCU boot will boot the primary image. So to start with, I will compile the MCU boot here. Now the compilation is done, and I'm going to flash the MCU boot to the discovery board. As you can see in the right side of my screen, you can see the MCU boot is booted, and it couldn't find any valid image in the primary slot because we haven't flashed any image in the primary slot yet. So now I will jump into the example for the MCU Manager MCU Manager example to showcase how compile and sign the image and then flash into the primary slot. To do that, I'm gonna compile this particular sample in the Zephyr 3 mainline. We have the board selected, and as usual, and then we have a couple of configuration explicitly selected in this case. Right now we have overlay for Bluetooth selected by default here, for example, because I'm gonna use MCU Manager over Bluetooth to download the image from the from my Raspberry Pi, and then upload the image to the STM32 target, discovery target, and then the new image will be flashed. So now I'm going to compile with the Bluetooth overlay. The next step is to sign the image before flashing it, because MCU boot basically needs all the image needs to be signed. So we need to sign the image with West sign utility here, and then I'm using the default provided key in the MCU boot directory. So now I've signed the image, and then we have the signed image placed in the same directory as in the build directory. So now I will flash, but this time I have to give the option --x file to point to the specific signed image to flash the signed image. So now you can see in the left side of the screen it's trying to flash the new image, and then right side of the screen, once the flashing is done, you will see the MCU manager example is flashed, and then now as like in the previous time we see there is no valid image in the primary slot. Now as we flashed the signed image in the primary slot, MCU boot tries to boot this image in the primary slot, and we have this example booted in the screen. So now I will make a small change to the program, maybe adding a name here just to see the next version of the image is updated fine or not after compiling it. So now again I will compile with the minor difference of the same application in the Zephyr, and I'm gonna sign it again, but this time we are not going to flash this image into the primary slot, but we have to sign it into, place it into the secondary slot or slot 1, and then we need to reset the target, and then MCU boot takes care of the swap operation, and then it boots the image which we flashed now. So how do we do this? I will now copy this image into my Raspberry Pi. I have copied this image into Raspberry Pi, and I'm gonna open my Raspberry Pi, and I have copied this here, and I have the MCU manager CLI client compiled and stored locally, which I will gonna use for few commands which comes as part of the CLI. First of all, we are gonna connect this STM discovery target over Bluetooth, and then I'm gonna run the command image list, and this will show us what is the current image which is currently flashed in the STM discovery board with some certain details about the flags, and then it is just like actively confirmed image and it is currently running, and the hash value of the image which is actually currently running. So now we're gonna upload our new image using the upload command, and then you can see the image is uploaded over Bluetooth to the STM32 discovery board, and now it will be flashed in the secondary slot during the transmission or on the fly. That's like flashing over streaming. So let's wait for a minute here, because the Bluetooth low energy is slow, because the chipset which is included as part of this discovery board is based on Bluetooth 4.1, and it takes some time before we upload the whole image. So maybe in the meantime I can quickly jump into the presentation and show where we are right now. Yeah, basically we are trying to experiment this MCU MGR example and over Bluetooth as the simple management protocols encoding and as well as the image management layer. So as we spoke in the session or the presentation, I'm using this example right away in the Zephyr mainline tree and then showing this to you. So the first image is like flashed directly to the primary slot of the flash, that is like slot 0, and then the secondary image, secondary slot image is actually flashed over MCU MGR. So let's see. Okay, now you can see the new image is completely uploaded and flashed into the secondary slot. Now that we can verify this with image list again, and then now you can see there are two images. One is the one which is currently running on the slot 0, and there is like a new image which we currently uploaded using the Bluetooth, and it is with a hash of different value. But you can see there is no flags attached to this particular image in the slot 1 because it's just uploaded and it doesn't have any particular flags. And what we have to do is we need to run a test check for this particular image by calling test and following with the hash value of the image. And then now we can see the image list with the flags to pending, which means like this image can run, but it's not yet confirmed because we need to reboot and see whether the image is valid image, and then it can boot fine, or we can use it for longer run, or our new application is working fine. So how we can do this is we can reset the target from here from Raspberry Pi itself by calling reset. And then now in the right side of the screen you can see the MCU bootloader finds this is like a test image found, and then it's gonna swap the new image, and it will boot the image which is flashed in the slot 1. So after swapping, so how we can verify this? Because we did a minor diff to our program earlier in the application itself to see whether our application is changed or not. Now we have the build time followed by Linux 2.0. It should be printed here, and yeah, you can find this information here. And then this is the new image which is flashed and booted. And now I'm gonna list the image again, and now it shows the image in the slot 1 is confirmed, but it's not like active confirmed. But yeah, like after the swap operation, now the current image which is running is the one which we flashed now, but it is active but not active confirmed state. For that we need to have like active image confirmed to make sure that like the new image is confirmed for our permanently. So for now I'm just gonna call image confirm, and then you can see the flag is changed to active confirm state. To check how the revert operation is working with MCU boot, one can just not confirming the image and just call the reset again, and during the next boot of the MCU boot you can find the MCU boot jumps into swap type revert, and then the old image will be reverted from the secondary slot by again doing a swap operation, and then MCU boots the old active image or old image which was working fine. So by this way we can make sure that there is no problem after uploading our new image. Say maybe our application is buggy and it resets in a loop and leaves the system in a brick state. So to avoid such cases, there is a state called revert, and then MCU boot jumps into the revert state, and it will boot the image which was actively running or working fine state before the upload. So this is how the MCU manager works, and then you can try with any other example similarly. Say for example, I am just gonna upload another image and see how revert works for us. So I'm gonna use hello world example now, and then for this we don't need an overlay, but the one thing which we need is selecting the bootloader. How do we do this? Is like there is a keyconfig entry for this. So by selecting config bootloader underscore MCU boot equal to y in the keyconfig entry, we make sure that the hello world example also can run under specific offset. Instead, like otherwise it will try to boot the image from the offset 0. So when we select config MCU boot, then it will look for the image at slot 0, otherwise it will look for the image at slot 0 across 0. So we need to link our image in such a way that it can be booted from slot 0. So that's why we need to enable this option. And now I'm gonna build it. I'm gonna build this image, and I'm gonna assign this image as like before. Okay. There's a typo. So now I assign the image, and I'm gonna copy this new image as maybe hello.bin instead of the same name into my Raspberry Pi. Now we have the new image named as hello.bin, and we're gonna upload this new image to the STM discovery board. And then now you can see the hello world example is not as big as the MCU manager example, and the upload is quick. As like before, I'm just gonna list the image which is currently flashed, and you can see the flag is empty, and we're gonna test this image as before. And I'm gonna reset the target, and now the MCU boot tries to swap the image from the secondary slot to the primary slot. And now you can see the example currently running is hello world, but this time I'm not gonna confirm this image over Bluetooth, and the example which we flashed is simple hello world, which is not capable of connecting to our Raspberry Pi over Bluetooth. So I'm just going to manually reset on the target by pressing the reset button once, and now you can see the swap type jumps into revert mode, and then during the revert operation, the image which we currently flashed, that is like hello world, is actually not stable, and detects as like not stable, and it reverts back to the previously flashed MCU manager example. So now you can again see the image in the list, and the image which we flashed is actually not confirmed, not pending, or not tested, because we have an image which is not good. We testified that this image is not so good for the operation of testing. So this way we can just make sure the device is not bricked in this case. So that's how the MCU manager example can be used. But for the real world cases, one can use the sample here, which is listed in the MCU manager, and use over on the specific application purpose, and use the OTA. So from the Raspberry Pi point of view, one can build an application which is based on the MCM manager system, and they can build a client based on the rollout mechanism, and give a rollout for multiple devices over Bluetooth. So now we will jump into UpdateHub, and how we can see how UpdateHub actually can be used. And although this was shown in the session, I will repeat this for completeness. As mentioned earlier, for this I'm just going to use the Freedom Development Kit K64 board. So I'm just gonna I'm disconnecting the STM discovery board. I'm connecting the FRDM K64 board to my system. So now to see the system working, and I'm just using the same console to just maybe I can clear it once, and yeah. So now I'm gonna build for the target F4DM K64 in Zephyr, and I'm gonna flash this image. And now you can see the target Freedom Development Kit is booted with the Hello World example. So as we did before, and then we are gonna first flash the MCU boot into the Freedom Development Board. So for that, I'm gonna build the MCU boot again for the Freedom Development Board. And I'm flashing the MCU boot first. And now you can see, as like before, the MCU boot is booted, but there is no valid image in the primary slot. Now this time I'm gonna jump into the UpdateHub sample, and what we have to do is we need to tune a couple of configuration files to make sure that we are connecting to our local server. So before that, to show as an example, I have an UpdateHub running in my local system, and you can see this is already booted fine, and the UpdateHub UI is available. So the login is admin, and then you can see it is looking for devices, and there is no devices found in the UpdateHub server. So this is currently running in my system or this particular IP address. So we have to give this particular IP address, or you can copy the whole instead of using the overlay configuration, one can just copy this and place in the proj.config, and I'm just gonna change the IP address into the machine where the UpdateHub is currently running. That's my local system. And I'm gonna compile again for the FRDM board. And then, as before, we need to sign the image first before flashing it. Now the new image is signed. I'm gonna use west flash --bin file and provide this bin file to flash it. And you can see the image in the primary slot is now valid and it's booted fine, and it's going to connect to the UpdateHub server, which is running in my local system, and it's going to say there is no update available because we haven't pushed any new images for the system. So to check this, we can find the device is now available in the UpdateHub UI, and you can see the details about the device and the UID of the device as well. So now we have to create a new package for this UpdateHub and create a rollout mechanisms and to start updating the device from here. So how we can do this? We have to create another image, probably now with the build time, just to make sure that this new image is compiled and flashed over. So what I'm gonna do is I'm gonna compile this again, and maybe this time I'm gonna place into some different directory instead of the same directory during flashing. And I have compiled it, and as usual we are gonna sign this image, but our new build is available in 2.0 directory, and now we have the signed image. But before uploading this image, UpdateHub expects this to be in a certain format like a package, so that the UpdateHub understands the package in such a way it encodes some certain information. So for that, we're gonna follow the steps which is provided in the documentation as it is, and it needs some certain packages. So I'm just gonna use the same step as it is, which is provided in the Zephyr documentation for now. And we're gonna give the new image which is built with some changes, and that's the image which is compiled with changes. And I'm gonna create the version, Okay, so now I realized I did a mistake before flashing the primary image and as well as the secondary image. So what was that is we need to give a version to our image while flashing it, so that the system can detect, or the UpdateHub application can detect. So this was the earlier mistake during the session as well, and the target went into a loop reset. So to avoid this, maybe I can flash the first image as 1.00 as a version, and to make sure that I'm just gonna kill this device here in the UI already by just exiting the UpdateHub Docker instance, and then I'm gonna restart the Docker instance here and wait for it to start. Now it started again, and you can see there is no devices again. Still, I will repeat it once more. Probably it's cached. Okay, this time it's still my target is still running, which means it's enumerating and quickly available on the server. So for that, I'm just going to disconnect the target and stop the UpdateHub server completely, and I'm going to flash the target alone before bringing the UpdateHub server up and running. So now we signed this image. I'm gonna flash it again. So now we flash this image, and I'm gonna start the UpdateHub server. And yeah, so this should be our new device, which is enumerated here. And to make sure, maybe I'm just resetting the target once more, and you can see the device here. Now we're gonna create the version 2 of the image. So now we have version 2, and I'm gonna assign this image and gonna flash this to mark it as 2.0 version, and the image is located at 2.0 directory. And now I assigned it, and we're gonna repeat the same step which we did before for the UpdateHub. And then I'm gonna create the final package which can be used. So now we have the package which can be uploaded here. So one can run git status here to see what's happened in this file particularly. You can see this is the metadata file which is used by the UpdateHub to find which is the version and what is the file name and so on, and details about that file. And this information is appended as part of the package. And the UpdateHub application which is currently running here make use of this particular metadata information to use it for uploading the new version of the image. So now I'm gonna upload this new image here, and I'm gonna create the rollout. And you can see the application, the UI says this, the new update is running and it is currently pending for the update. And now it's probed metadata received, and I think the new image is flashed here right now, and is currently in updating state here. And now you can find the build time details available, which means our new image is updated, and you can see the flag is checked, stating that the new image is updated. So, and you also see this information in green. So the new rollout is done. So our target is running the new image. Assuming if you wanted to revert like before, or the image is corrupted also, and then the MCU boot detects, and then the system restarts, and then as like before, it will jump into the swap type revert state, and then it will revert back to the old image. So this is how it works. So I haven't done anything special apart from just following these details which is mentioned in this particular Zephyr documentation in terms of UpdateHub. So now we can jump into the Hawkbit example, which was missing during the presentation, or which I couldn't show during the presentation's timing. So maybe to give an overview, we are currently working on a Z update architecture, which can create a unified software update mechanisms for Zephyr, and which is currently in progress. And we initially kickstarted with Hawkbit as an use case to kickstart the architecture Z update. And we have the initial version of Hawkbit, which can be directly run like UpdateHub now, but without the Z update architecture itself. And this Hawkbit example is done in such a way that it can be extended to the Z update architecture. For now, we're gonna see the Hawkbit example and see how it works. So to see this, and I have as like UpdateHub, I have in the right side of the screen, I started running the Hawkbit in the Docker instance, and you have the Docker Hawkbit UI here. So again, the same login, admin and admin, and you can see the Hawkbit UI in the screen. First of all, to get started with the fresh scan, I will jump into the hello world example, and I'm gonna take off this MCU boot flag, and I'm gonna build it for FRDM board. Just to make sure that we are starting fresh. So I'm gonna flash this image, and it's gonna change the image in the target, and now we have the hello world example. So now we will start from the beginning, just like before. We will build the MCU boot, and flash the MCU boot directly, and now you can see the MCU boot is booted, and there is no valid image on the primary slot. And I'm gonna jump into my just clean this changes right now, and I'm gonna check out into demos, because Hawkbit is not yet there in the mainline Zephyr, and we are currently working on it to get it to the mainline, which is not yet there. So for that, I just jumped into my private branch, but one can find this information already in the presentation and find where exactly our PR is. So I'm state of the PR of the Hawkbit. So I now pulled this PR locally, and then amended to my Git history, and also to show here the Hawkbit server is currently running in my another laptop or another system here, and I'm just providing the Hawkbit server IP address here. So what we're gonna do is, as like before, we're gonna build the image for DM board. And we need to sign the image. And this is not in the 2.0 directory. And I'm gonna use the default key. Now the image is signed. Now I'm gonna flash. Okay, now I flashed the bin file instead of the hex file. That's why it says the image is not valid. And now we can see the Hawkbit sample is started, and you can see the Hawkbit is pulled for the server. Now we will jump into our Hawkbit server, and you can see the device is already populated here, and you can find the information about this device, like what is the IP address which is connected with, and so on and so forth. So currently it is not running over TLS, it's just running in my local system with plain HTTP, but TLS can be enabled by running the Hawkbit in TLS and also providing the certificate files in the Hawkbit example. So we need to upload the new image now. For that, I'm just gonna change a minor thing as before, like having a build time and date time printed during the build, so that we can differentiate the new image. So I'm gonna build this image into the same directory, probably to make sure I can build it to a different directory as well. Now I'm gonna assign this image, and our new image is in the 2.0 directory, and I'm gonna copy this binary directly into the Hawkbit server. So for that, I'm copying it into my root directory or home directory. And to have the Cockpit working, there is like a plenty of options in terms of rollout and rollout mechanisms, but I'm not going to explore all of these options about rollout and updating the multiple system and how do we do it. But for now, I'm just going to create some simple upload and simple distribution just to make sure how do we use this. So this is an application which we're flashing into the target. So I'm going to call it as Luminous, and the version maybe 3.0 because the current version, just to make sure the difference. And I'm going to upload the new binary here, and you can see the new image is uploaded here, and we need to create a distribution. So this way you can have multiple distributions with the same image or a combination of image and so on and so forth. So this is like a flexibility which is provided by plenty of flexibility provided by the DDI interface of Hawkbit. So and what I can say is like this is Hawkbit Luminous sample, and the version is same maybe, and we need to map the upload module. So when you upload a new module, and here in the upload UI and upload the new file, it will appear here here in the distribution window. And once you create a distribution, you need to map this particular image directly to use which distribution to which image. And then I'm gonna use this one. So when you click on the distribution, it just marks green to show that it is mapped already. So as like before, you can see the devices appeared after pulling after publishing some details from the target here, and our new distribution appears. So now I'm just gonna upload this new distribution to our device, and there are plenty of options. You can say timed update or download only, or soft update, which means like soft means it just updates the image but doesn't reboots, and so on and so forth. There are plenty of options here. There is also a rollout which we are not gonna see here. And now I uploaded the new image, and you can see the new image is currently in progress for updating here, and as it is in polling mode, it can start it on own. And I also we can also explicitly call it by manually running Hawkbit run. So when you run Hawkbit run, it is gonna poll the server explicitly and see if this image is if there is any new image available, and it's gonna pull this image and flash into the secondary slot. Now we need to wait for some time, and now you can see the image is installed and certain sectors of the flash is erased, and you can reboot the target now. And when you reboot the target, you can see the swap type is in test, and our new image is flashed because we can see the build time is added, which is added in the second version of our image. And when you jump into the Hawkbit UI, now you can see there is a status tick mark, which means in the green, which means the image is updated and your target is up and running well and good. So when you update an image which is corrupted and it doesn't work well, you can send a status to the server that like it didn't update well, and mark it as failed update, or you can find the activity here in the active window as well. So now we have the new image flashed in the target. So maybe I can simply reset it and then see it now still runs in the none state, because we already as part of the sample we confirmed this image is working as okay. But when developing an application using Hawkbit as a secondary or OTA cases, where we can say whether the image is updated fine or working fine or not, explicitly calling the APIs which we discussed during the session. For example, here, so we call the request update, and then we can call it as like right image is confirmed to make sure the different state of the image, to confirm state or failed state, or so on and so forth. So this can be used in the application or as a callback mechanism for the Hawkbit, and then trigger the software update, and then we can wait for the update to be completed, and if it fails we can just say mark it as failed and then reboot into the old image, or we can maintain the device in non-brick state. So that's all I have for now. Thank you very much.